Here is your kind of general form of an exponent. Okay, terminology-wise, I'll probably, when I refer to exponent, I kind of mean this whole thing. Exponent deals with repeated multiplication of a single base. If I want to talk about the individual pieces of this, the value that's being multiplied by itself is called the base. The number of times that it's being multiplied is called the power. And that's usually how I'll refer to it. So by itself, exponents simply represent repeated multiplication. So this base A is being multiplied by itself n number of times. So if I were asking you to represent 5 cubed is really 5 being multiplied by itself 3 times. Okay. There are certain types of repeated multiplication or exponents that I expect you guys can evaluate without using a calculator. All perfect squares up to at least 12 squared. And then all perfect cubes up to 6 cubed. You should be able to do just mental calculation or no. And the perfect cubes, perfect squares you shouldn't need to review at all. Perfect cubes, 2 cubed is 8, 3 cubed 27, 4 cubed 64, 5 cubed 125, and 6 cubed is 216. Beyond that, you can just leave things written in the form of their exponent. Okay, so what that means is if I asked you if you solved something and you came up with 5 to the 5th, you could leave it in that form. I'm not asking you to evaluate it without a calculator. And if you were entering this on your online, use a caret symbol for the power. So 5 to the power of 5 would be the way that you would express that. Okay. All right, questions just about this in general, what an exponent looks like and the different pieces of it, what it represents. Again, should be pretty self-explanatory. All right. I'm going to break down the properties that I want to go through into 4 groups of 2 and just talk about them individually or in those pairs. Okay, the first is if I ask you to, or if you're asked to multiply 2 exponents that have the same base, they may or may not have the same powers. Okay, so this would be something like 5 cubed times 5 to the 5th. Okay, really what you're looking at, if this multiplication is repeated 3 times and this one is 5 times, then the total number of times that 5 is being repeated is going to be what? 3 plus an additional 5. So the pattern for this, when you multiply exponents with the same base, you add their powers. Okay, the other property that I want to start by looking at or reviewing, and again, this should all be review for you. If for some reason you haven't covered any of these types of properties and you have questions about it, make sure you ask me. I'm more than happy to go into more details on these, but I'm going to limit it a little bit here. Okay, when you have a negative power, the negative power does not change the sign of your answer. So 5 to the negative third is not negative 125, which is, again, it is a common mistake. Okay, all a negative does is it moves your base from the numerator to the denominator or vice versa, from the denominator to the numerator. It takes the reciprocal of your base. So a to the minus n is just like saying your base a, it's going to move it from the numerator to the denominator. And then when it does that, once it applies that change or adjustment, it becomes a positive power. So 5 to the negative third is equivalent to 1 over 5 cubed, which could then be evaluated 1 over 125. Okay, this works from the denominator up as well. So if I had something like this, if I had 3x y z to the negative, let's say 3x squared y cubed z to the minus 2. Okay, if that's my expression, I want to simplify this. Okay, the 3 and the x squared, nothing happens to those. They stay just as they are. The y cubed stays just as it is. But this power of negative 2 for our base z is going to take our z, it's going to move it from the denominator up to the numerator and change its power to a positive number. And so it can move from the numerator to the denominator or from the denominator to the numerator. All right, if we take a look at problem 2, here we're dealing with negative powers. Okay, so our base of 2, and we have a power of negative 4. So that negative power is going to move our base into the denominator, change the sign to positive. Now, the perfect squares and perfect cubes up to 6 cubed, I expect you to know. Things to the power of 4, 5, other numbers, you don't need to know unless they're easy to manipulate. So 2s and 3s as your bases, I may expect you to be able to do that. 2 to the 4th, definitely you can do. I mean, if you just kind of work through it. 2 times another 2 is 4, times another 2 is 8, times another 2 is 16. And so you could simplify this to 1 over 16 as your solution. Okay, moving to the next term. Again, just straightforward. Your base is t. Since it has a negative power, we're going to move that base of t to the denominator, change its sign to a positive 7. Okay, if you're asked to write this online, the way that you would write it is 1 divided by t to the power of 7. You don't need any grouping symbols or anything here. That's all you would need in order to express that fraction online. Okay. In part C, here we have an entire base. The base itself of this exponent is binomial. It's 2 terms. So that entire base has this negative power applied to it, moves the entire base to the denominator, and then changes the sign of the power to a 2. You don't need to expand it out any further. You can leave it just like this. Again, if you were looking to express this online, 1 divided by, now because your base has multiple terms, you would need to put grouping symbols around it, so parentheses, and then to the power of the caret symbol 2. Okay, the final example here, our base is e. It's an irrational number, but it still fits this pattern. We move our base to the denominator, change the sign of our power. So you get 1 divided by e to the 2t would be your simplified expression. Okay, moving to the other rule, the multiplying. Okay, if you're multiplying 2 exponents with the same base, you're going to combine you'll combine their powers by adding. So t to the 4 plus 5, again, just a real straightforward. T to the 9 is your simplified form. Here you have a negative power and a positive power. Again, anytime there's nothing written, if you think of what the exponent stands for is the number of times a number or a base is multiplied by itself. If it's just the base itself, that unwritten power is 1. So here, when we multiply exponents with the same base, we're going to add the powers. Negative 4 plus that unwritten 1 gives us t to the minus 3. So you could either write your form of this, t to the power of negative 3, and you would have to put grouping symbols on it. Or actually, it should accept it either way, with or without grouping symbols. Or you could also rewrite this so that it has positive powers. The power of negative 3 takes our base of t, moves it to the denominator, changes the sign. So 1 over t cubed would be an alternate form for that answer. Okay, the final example, here you're multiplying 2 expressions. They do have a common base of t, but they also have numerical coefficients. You can just combine the coefficients themselves. So 10 times 5 gives you 50. And remember, you're dealing with commutative property. You can reorder multiplication. So 5 times 10 gives us 50, and then apply the properties of the common base for an exponent. When you multiply, you add their powers. So negative 3 plus a negative 9. That's going to give you 50t to the negative 12. So here's one potential answer. Because it's a negative power, you could also express it in terms of a fraction. 50 stays in the numerator. Our base of t, because it has a negative power associated with it, will be moved to the denominator, change the power to a positive. And so 50 over t to the 12th would be an alternate form for that as well. Okay, questions on those 2 properties?